So last day I introduced the budget line. The budget line is xpx plus ypy less than equal to I. The right hand side is the income side and the left hand side is the expenditure side of the budget. So to begin with, I can consider the unit price of X is 2, whereas the unit price of Y is 1, and income of the consumer is 8. So in that case, I'll write the budget line as 2X plus Y less than equal to 8. Now, if income changes to 6 units, the budget line will become 2X plus Y is equal to 6. On the other hand, if price of Y increases to 2 per unit, in that case, there will be a change in the slope of the budget line. Last day, I stopped with the idea of shift of the budget line and the rotation of the budget line. If other things remaining constant, if there is a change in income, that will be captured by the intercept of the budget line. So we will have a parallel shift of the budget line. If income falls, the shift will be to the leftward direction. If income rises, the shift will be to the rightward direction. Okay. And I also mentioned other things remaining constant. If there is a change in PX, in that case, there will be a change in the slope of the budget line. So if Px falls, other things remaining constant, that means slope is becoming flatter. So budget line will swing to the outward direction. On the other hand, if Px increases so that there is an increase in the slope of the budget line, in that case, the budget line will rotate to the inward direction. Okay, so if Px increases, it will rotate to the inward direction. If Px falls, it will rotate to the outward direction. If income falls, it will shift to the leftward direction. If income increases, it will shift to the rightward direction. Okay, so today I'll consider the similar idea. However, I am starting with this point. Bundles below the budget line are affordable. So we are trying to identify the feasible set of consumption. So if AB is the budget line, all the points below the line AB, all the points, all these points below the line AB and the points on the budget line AB are feasible consumption points. So the consumer will be able to afford, this combination of XY or this combination of XY or this combination of XY. So any point, any coordinate XY below as well as along the budget line are affordable consumption points, So we call this feasible solutions. The amounts of X and Y which are below and on the budget line are all feasible solutions. Okay, now what I am telling, if the budget line shifts, in that case, the zone, affordable zone or the feasible zone, that will also change. In this case, if there is an increase in price of X, the volume of feasible zone or the area under the budget line, that is reducing. So other things remaining constant, if price of X increases, in that case, there will be a shrink in the affordable zone. On the other hand, other things remaining constant, if there is a reduction in PX, the budget line will become flatter and the affordable zone will increase. Similarly, if income falls, other things remaining constant, in that case, the affordable zone is falling On the other hand, if income increases, in that case, the volume or amount of affordable zone that is increasing. So remember, the budget line is the boundary to the affordable consumption points. All the points below the budget line and on the budget line will be feasible for consumption. However, a combination of XY which is beyond the budget line is not affordable to the consumer. Any point here, any point here or any point here, these points are not affordable to the consumer. Next, having the budget line and the indifference curve, in the next step, we are trying to find out the optimum solution for the consumer. We are trying to find out the optimum solution for the consumer, okay? That is, I have the income constraint, I have the idea of the income constraint, and I have one utility function. So given my utility function and the income constraint, in the next step, we will try to find out utility maximizing solution subject to the budget constraint. Utility maximizing solution subject to the budget constraint. So now we are trying to derive an equilibrium purchase point of the consumer. We have different possible amounts of X and Y, and that is generating my utility function. Okay, different for different combinations of X and Y, I will be able to generate my utility function. Now, given this utility function and given the knowledge of my budget, how I will maximize my satisfaction, how I'll find out utility maximizing amounts of X and Y subject to the income constraint. So now we are going towards the optimum solution. Given a budget line and given an objective function, how to derive an optimum solution. And this will be considered as consumer's equilibrium. This will be considered as consumer's equilibrium. So let's try to understand the matter first graphically. So this is the two commodity space, and suppose this is my budget line. And from my utility function, I will be able to generate, using my utility function, I will be able to generate a set of indifference curves like this. So this is my two commodity world, X and Y being two commodities. AB is the budget constraint or income expenditure equality line. AB is the income expenditure equality line. And on the basis of utility function, U is a function of X and Y, I can generate the indifference map where along each of the indifference curve for different combinations of X and Y, my utility remains unchanged. Along an indifference curve, say IC1 or IC2, IC3, for different combinations of X and Y, the satisfaction or the utility will remain unchanged. However, a higher indifference curve definitely implies higher level of satisfaction. So any point along IC2 will be preferred to any point along IC1. Similarly, any point along IC3 will be preferred to any point on IC2 or IC1. However, along IC1, for different combination of X and Y, my satisfaction will be similar. Along IC2, for different combination of X and Y, my utility or satisfaction will remain unchanged. And similar thing will happen to IC3. And there are infinite number of curves like this. There are infinite number of curves changing the combinations of X and Y. We can generate infinite number of indifference curve in a two commodity world. Now, the three curves I have considered, if I compare these three curves with respect to my income constraint, what I am finding that both IC1 and IC2 are based on feasible solution. However, IC3 is totally beyond the budget line, and therefore we will be not able to generate any feasible solution out of IC3. So any indifference curve which is not even touching the budget line, far beyond the budget line, is not indicating combination of commodities which I will be able to afford. So IC3 is not affordable to the consumer. Now, if I consider the combination of commodities along IC3, like this point, or this point, or this point, or this point, or this point. Okay, sometimes it's becomes so difficult to identify the points. Okay, so this point, are these points feasible? Are these points affordable?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
So because all these points are either interior to the budget line or it is on the budget line. So all these points are feasible consumption points. Feasible consumption points. Okay. Now our task is max this subject to this. Xpx plus ypy is equal to I. We can start with less than equal to I, and then I'm telling how I can consider only the equality constraint as well. Okay. Now, if I consider IC2 instead of IC1, we are getting a point of tangency between the indifference curve and the budget line at the marked point. Okay, we are getting, a point of tangency between the indifference curve and the budget line. Now, if we compare all feasible consumption points at this moment, what we are finding that, now here I am getting, if I consider a point like this inside the budget line. Now, along the indifference curve, I can increase my consumption of Y and I can come here. And alternatively, I can increase my consumption of X and I can come on the budget line as well. So we are getting a set of points, which are all feasible. So since all these points are lying on the same indifferent curve, all these points are equally likely to the consumer. So we will be not able to define any of these points as optimum solution. A point like say M, where the IC is cutting the budget line, or a point like say N, again where we are getting that budget line or indifference curve is cutting the budget line, or a point like L, M, L, N, among these points, the consumer will remain indifferent. So we are understanding none of the point is giving us the utility maximizing solution, because utility maximizing solution will be a unique one. So given the different combinations of the two commodities and given my income, I want to find out a maximum. I want to find out utility maximizing solution. Now, if I consider an IC like IC1, where IC1 is cutting the budget line, we are finding the point on the budget line, point inside the budget line, all these points, just like M, L, N, all these points are equally likely to the consumer. So none of the point is basically giving the consumer an optimum solution. Now in this way, and I have a possibility that another point we should note that if I move to say IC1 prime, again I'll get higher level of utility because IC1 prime lies to the right of IC1. IC1 prime lies to the right of IC1 prime. Okay, so there is a chance that I like to move either from M to K or J, or in the similar fashion, again, I can draw an IC. Say IC double prime, IC1 double prime, which is above IC1 prime. Okay, so when the consumer is at M or N, there is a further chance that consumer can move to K or J and can remain on the higher indifference curve and thereby enjoying higher level of satisfaction. And the process can go on and on, starting from IC1 to IC1 prime, to IC1 double prime, IC1 triple prime, etc., etc. Now, in this way, when the consumer is moving to the rightward direction continuously or moving to the higher and higher indifference curve, finally, the consumer can reach along the indifference curve marked as IC2, marked as IC2. Now, at IC2, what we are finding that there is a point, say point Z, given the budget, this Z is giving the highest consumption possibility. So given the fact that the IC2 is touching the budget line AB, we do not have any further scope so that I can move beyond IC2. Any indifference curve beyond IC2 will be not affordable for the consumer. Any indifference curve beyond IC2 will be not affordable to the consumer. So IC2 is the highest level of indifference curve or highest level of utility which the consumer can attain. Given this budget line, the consumer can attain the highest level of utility along the indifference curve, which is generating a point of tangency between the budget line and the indifference curve, because all the indifference curve beyond this level will not be affordable to the consumer, will not be affordable to the consumer. Okay, so this is the idea. So we are getting some idea that in an indifference map, consumer will try to move continuously to the higher and higher indifference curve. And when a particular indifference curve will make a tangency between the budget line and the indifference curve, that is the maximum attainable level of utility. We have to stop there. We have to stop there because, you know, we will be not able to find out any other utility level higher than that which will be affordable to the consumer. So first tell me whether you are understanding which indifference curve I will select for my maximization of utility. Or whether you are understanding though all the points on IC1 or IC1 prime or IC2 prime are feasible consumption point, why I am moving towards IC2. Is it understandable?
Yes, ma'am.
Yes, ma'am.
Because that is the highest level of utility the consumer can attain. That is the highest level of utility the consumer can attain. So now I'm getting the idea of the indifference curve, which indifference curve I'll select. However, using some mathematics, I will show that this Z is the highest possible consumption point, you know, because if you consider any other point apart from point of tangency, say a point like this or say a point like this, the problem is these points are not affordable given the budget constraint. All the blue points are beyond the budget line. Okay, Z is reachable point for the consumer. Okay, so though the entire IC2 is giving similar level of satisfaction to the consumer, given the budget constraint, the combination which the consumer will be able to afford, that is given by Z. Though all the points along IC2 are equally likely to the consumer, all the points are not feasible for consumption. A point and only the point Z along IC2 is affordable for the consumer because it is lying on the budget line. Okay, so given the fact that I have to maximize my utility subject to the income constraint, I will not only select IC2 but also select the point Z where finally I will consume. So logically, the point of tangency between the indifference curve and the budget line therefore is giving me utility maximizing solution subject to the income constraint. Now, what is the tangent of the indifference curve? What was the value of the tangent of the indifference curve, or what is the value of the slope of the indifference curve?
U1 by U2.
1 by
U2.
this is given by which we also call MRSXY. The slope of the budget line, slope of the indifference curve. This is the next. I'm considering the slope of the so this is the slope of the budget line minus dy by dx is equal to px by py. At z, the two curves are tangent to each other. This implies at z, the slopes of the two curves are equal. Is equal to each other. This finally indicates at z, MRS XY MRS XY is equal to Px by Py. At Z, the two curves are tangent to each other. This means at Z, the slopes of the two curves are equal. That means at Z, MRS XY is equal to Px by Py. And this is the required utility maximizing condition subject to the income constraint. On the other hand, or we can say that this idea, this equality between the MRS and Px by Py gives consumers equilibrium. At MRS XY is equal to Px by Py, the consumer will be at equilibrium. So MRS XY is equal to Px by Py is the utility maximizing solution subject to the budget constraint. This means this is giving the consumers equilibrium purchase of X and Y. So any question? You are understanding this matter? Understanding the logic, how we are generating or getting or deriving consumers equilibrium?
Yes, ma'am.
Yes, ma'am.
Clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so let's move to the slide. So we are starting to talk about consumers optimization, and here we are trying to find an interior solution. Interior solution means combination of X and Y, not a single commodity solution. Not only X at equilibrium or not only Y at equilibrium. At equilibrium, consumer is consuming both the commodities. If this happens, that means we are considering an interior solution. Interior solution, combination of both the commodities X and Y, like the point Z, where the consumer is consuming both the commodities X and Y. Sometimes it will happen that at equilibrium, consumer will consume only X, or at equilibrium, consumer will consume only Y. So these solutions are called the single commodity or mono commodity equilibrium. So now we are not talking about mono commodity equilibrium, or now we are not talking about any corner solution. Now we are talking about a standard interior solution. So now the consumer's problem is how to be as happy as possible with limited income. We can simplify the problem into language of mathematics as max utility, which is a function of xy subject to xpx plus ypy less than equal to I, x greater than equal to 0, y greater than equal to 0. X and Y are amounts of commodities. So the minimum possible amount is 0. So X and Y cannot be negative. Okay. So we are keeping in our mind while we are going for this kind of solution, we are generally considering X is greater than equal to 0, Y is greater than equal to 0. Since the preference has non-satiation property, only xy on the budget line can be the solution. Because, as if you consider a point which is below the budget line, there is always a scope that you can increase amounts of both the commodities. And finally, when you are on the budget line, that is giving you, the satisfactory solution, because, you can move towards the budget line, increasing consumption of both the commodities. So actually, while we are trying to find out the equilibrium solution, though all the points below the budget line are all feasible solutions, we will not consider those as equilibrium. We will like to have an equilibrium on the budget line only, because that is ensuring us we will be not able to move beyond this line. We are on the constraint, It is not possible to increase consumption beyond this line. So it will give us that kind of idea, and therefore, as a rational consumer, we will like to select a point on the budget line. So what we can do, from the inequality constant xpx plus ypy less than equal to I, we can limit my choice on the line only, and therefore I can rewrite the budget equation as xpx plus ypy is equal to I. So therefore we can simplify the inequality to an equality and present the budget equation as xpx plus ypy is equal to I. First, consider a case where the solution is interior, that is both x and y are greater than 0. There is a possibility that x and y are greater than equal to 0, indicating we can have x equal to 0 while y positive, or y is equal to 0 when x positive. So to begin with, I am not considering those special cases. I'm not considering any corner solution. I am starting with interior solution. So to start, we are considering both x and y are strictly positive. Now there are three methods by which we can derive consumer's equilibrium. The most intuitive is this one, the way I explained getting the consumer's equilibrium. That is the most intuitive one. So let's start with that. The utility function reaches its maximum when the indifference curve and the constraint line are tangent to each other. Now, tangent means the slopes of the two lines are equal to each other. The absolute slope of the budget line is px by py, or minus dy by dx is equal to px by py for the budget line, whereas the same slope minus dy by dx is equal to ux by uy or mux by muy or mrs xy for the indifference curve. So the solution can be written as px by py is equal to mrs or px by py is equal to ux by uy, which is equal to mux by muy. This ux notation is indicating mux. This is also indicating del u by del x, uy, del u by del y. So this is equivalent to mux and muy. So this is consumer's equilibrium. This is the consumer's utility maximizing solution subject to the income constraint. This is the first method. Now, before moving to the second and the third method of solving this or reaching at this equilibrium, let's try to explain a few points around the equilibrium solution. Why the equality between px by py and ux by uy is becoming as an equilibrium solution. Mathematically, we are understanding this is the highest reachable point, and for that matter, this will be considered as the equilibrium solution. However, intuitively also, we need to understand why px by py greater than ux by uy or px by py less than ux by uy are not equilibrium solutions. So let's first start with px by py greater than ux by uy. Now try to understand the matter, okay, carefully. Px by py is the relative price of x with respect to y. Relative price of x with respect to y. On the other hand, okay, so px by py to any consumer is relative price of x. That is how much I am paying with respect to the price of y, how much I am paying. On the other hand, mux by muy is the valuation of x with respect to y. Now, as long as px by py is greater than ux by uy, this indicates consumer is paying more than the value he or she is getting out of one additional unit of consumption of x with respect to y. I'm repeating. Px by py is how much you are paying to get an additional unit of x with respect to y. How much you are paying to get one additional unit of x with respect to additional unit of y. How much you are giving to the seller for getting one unit of additional x compared with the price of y. This is the left hand side. On the other hand, the right hand side is what additional satisfaction, marginal utility, what additional satisfaction you are getting consuming one additional unit of x with respect to an additional unit of y. So if you feel that the price you are paying for X, the relative price you are paying for X is greater than relative satisfaction you are getting out of X, in that case, being a rational consumer, you will continuously reduce the consumption of X. You will reduce the consumption of X, because to you, what I am paying, that is more than what satisfaction I am getting out of this payment. What satisfaction I am getting out of this payment. So as long as your feeling is like this, you will continuously reduce consumption of X. On the other hand, if Px by Py is less than Ux by Uy, then your feeling is what I am paying, that is less than what satisfaction I am getting out of it. What additional amount I am paying, that is less than the additional satisfaction I am getting out of this consumption. So if this happens, naturally being a rational consumer, you will like to increase consumption of X. Okay, and you will be able to reduce consumption of X. That means you are increasing consumption of Y. You are increasing consumption of X. That means you have to reduce your consumption of Y. So in the first case, you will reduce consumption of X and increase consumption of Y. Or you will substitute X by Y. On the other hand, in the second case, when you are increasing your consumption of X, that means you are substituting some of Y by X. Okay, so both the cases are indicating you are not settled. You are continuously substituting one commodity by the other. So it cannot be the equilibrium solution. Equilibrium means a state where you will, given this utility function and given this money income, you will not change it further. You will not change it further, because this is the most satisfactory point given your income. However, what we are getting in the last two cases, either you are continuously reducing your consumption of X, or you are continuously increasing your consumption of X, which means you are not at an equilibrium state. So this logic is indicating equilibrium will be obtained only when Px by Py is equal to Ux by Uy. So when the amount, additional amount is you are paying, that is exactly equal to the additional valuation or additional satisfaction or additional worth of the commodity to you, in that case you will stop. In that case you will stop. So only Px by Py equal to Ux by Uy can give you the equilibrium solution. None of the below, that is Px by Py greater than Ux by Uy or Px by Py less than Ux by Uy, can give the consumer the equilibrium solution. So, Px by Py greater than Ux by Uy, that means you are paying more compared to the satisfaction you are getting. So you will consume more Y, less X. On the other hand, Px by Py less than Ux by Uy, that means consumer will consume more X and less Y. Intuition behind Px by Py is equal to MRS. Px by Py is the market price of X in terms of Y, and MRS is the price of X in terms of Y valued by the individual. MRS means UX by UI. So MRS is the price of X in terms of Y valued by the individual. So left hand side is actually how much you are paying. Right hand side, you are judging the worth of the commodity to you. So if PX by PY is greater than MRS, X is relatively expensive for the individual, and hence he should consume more Y. On the other hand, if PX by PY is less than MRS, X is relatively cheap for the individual, and she should consume more X. So this is the idea. Okay, so we are judging the worth with respect to the price we are paying, and when we are finding that the worth is similar to that of the price I am paying, in that case I'll stop and I will be able to get my final solution, equilibrium solution. Once I reach at this solution, I will have no incentive to change it further. I have no incentive at all to change it further. Therefore, Px by Py is equal to MRS, or Px by Py is equal to Ux by Uy, gives the consumer the maximum level of utility subject to the income constraint. Any question? Any question? Anything? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So graphically, mathematically, intuitively, y px by py is equal to mrs xy is consumer's equilibrium. I hope that you are understanding. Now there are different methods to get the same solution. So you will learn, several methods in your math eco class, several methods you will learn in your micro class, or I'll tell you about the method. However, more you will learn in the mathematical eco class. So all these things are there. So I'm giving you some hint. The first method is more crucial for your micro understanding at this level, because the second method we will elaborate more in mathematical economics class, which we will have in the next semester. However, just look at the technique, So method 2 is use of Lagrange multipliers. This is method 2. Now, what is this method? I have one utility function and I have one budget line. Lagrange, a famous mathematician, what he did, he joined the budget constraint with the utility function. He is telling that, yes, there are two functions. One is the utility function and another is the income constraint or the budget constraint. Now, instead of treating two functions, I'll add the two functions using a multiplier, which I'm calling Lagrange multiplier, and generating an adjusted objective function, So what he did, he added the utility function with the income constraint, okay, using the Lagrange multiplier. So he presented the new equation in this way, capital L. L is the new objective function combining the original objective function and the budget constraint. So u of xy is there minus lambda. Lambda is the Lagrange multiplier, then xpx plus ypy minus y. Now, our income constraint is given by xpx plus ypy is equal to I. So when I am joining the two, I am writing the expression as minus I is equal to 0. Okay, now if I write the expenditure part first, then minus income, I have to present the Lagrange multiplier with this minus sign. Alternatively, this equation can be presented as I minus xpx minus ypy is equal to 0. So if I consider this formulation, in that case, I have to write plus lambda I minus xpx minus ypy. You will get the same solution. However, you need to adjust the sign of the Lagrange multiplier in this way. If you write the expenditure minus income format, the Lagrange multiplier will come with the minus sign. If you write the expression as income minus expenditure, in that case, your Lagrange multiplier will come with a positive sign. Lambda is the Lagrange multiplier. Now, for any kind of maximization, the idea is same. With respect to the variables of the model, we will take differentiation. We will get several first order conditions, and solving the first order conditions, we will get the equilibrium solution. Okay, so here, once I get this new objective function, I'll take derivative of this objective function with respect to x, and by FOC, first order condition, I'll set this equal to 0. Now, as I do so, if I take derivative of L with respect to x, I am getting del u by del x minus lambda px. Del u by del x minus lambda px is equal to 0. So del L by del x is equal to del u by del x minus lambda px is equal to 0. Okay. Now this is nothing but ux, or ux is equal to lambda px, or ux by px is equal to lambda. So this equation, ux by px is equal to lambda. Similarly, if I take derivative of this L with respect to y, we are getting del L by del y is equal to del u by del y. U is function of both x and y. U is a function of x, y. So del u by del y minus lambda py is equal to 0 by FOC. And from there, or uy is equal to lambda py, or uy by py is equal to lambda. Okay. In case of Lagrangian multipliers, we also consider the derivative of L with respect to lambda, which is giving back the budget constraint. Xpx plus ypy minus I is equal to 0. If I take the derivative of L with respect to lambda, we are getting back the budget constraint given by xpx plus ypy minus I is equal to 0. Okay. Now, if I consider these two equations, if I consider these as equation 1 and this as equation 2, from 1 and 2, we get ux by px is equal to uy by py, or ux by uy is equal to px by py, or MRSXY is equal to px by py. So from 1 and 2, we get, since both the values are equal to lambda, we can write ux by px is equal to uy by py, and from there we are getting ux by uy is equal to px by py. Same equation which we got earlier graphically when we are trying to understand the matter, equality of tangency of the two curves also give the same solution. Px by py is equal to ux by uy. That is the solution which gives consumers equilibrium. Now, using a sophisticated mathematical tool also, we are getting the same solution. Question is why we are going for these mathematical tools, complex mathematical tools. The answer is, when I am doing this graphical analysis, I'll be not able to derive the second order conditions, and conceptually we are understanding the matter. However, I'll be not able to prove this, that the second order condition is also satisfied. The benefit of using the Lagrange multiplier or this kind of concept is we will be able to generate the second order condition, and we will be able to finally claim, yes, it is the utility maximizing solution. However, these we are not doing now. These we will do in the next semester. Just I gave you some idea. In this semester, you have everything which is based on graph and simple mathematics. Okay, so we are not going for the second order and how we derive the second order condition for these constraint optimization. I am not going for that. In this semester, you have unconstrained optimization only in your mathematical economics part, and ZH will talk about that. So in this semester, in the Math Eco part, you need to learn unconstrained optimization, and in the next semester, I'll talk about the constraint optimization when it will come in a particular context. Okay, so at this moment, just I want to show you there are different methods, and all the methods will give us the same result. Ux by uy is equal to px by py. This is consumers equilibrium. This is giving consumers equilibrium. Anything?
Yes, ma'am. I had a question. Ma'am, I was asking that del L by del X equal to 0. This gives the first order condition of maximizing that function capital L. Then why will it maximize U?
Just, would you please repeat the question once again?
Ma'am, I was asking that yes, ma'am, in this slide that del L by del X equal to 0 and del L by del Y equal to 0. These are the first order conditions of maximizing the function L. Then why will it maximize U?
Why we are maximizing U?
U using that. Yes, ma'am.
Okay, this is one method which we call constraint optimization method. What is happening? Consumers maximization solution is not a simple maximization. It is a constraint maximization. Max U xy subject to xpx plus ypy is equal to y. So there is one subject to part which was not there in your analysis of optimization at +2 level. You are directly maximizing or minimizing or optimizing a function, isn't it?
Yes, sir.
This kind of thing was not there. You have to maximize it. However, it's not unconstrained maximization or minimization. Subject to some particular thing you have to maximize. So this is subject to part is new here. Okay. So when the subject to part is new, in that case, while you are maximizing a function, you need to edit the function in such a way so that you can put or incorporate or internalize the constraint along with your objective function. Lagrangian expression is internalizing the income constraint along with the objective function which you want to maximize. So simply I'll be not able to use u for my maximization purpose. Rather, I have to consider an edited expression where I have to internalize the constraint along with the objective function. Lagrangian expression is exactly doing that job. It is merging the constraint using Lagrange multiplier along with the original objective function u. So once you get this edited objective function, now directly you can use calculus to maximize expression.
Okay.
Okay, got it?
Yes, ma'am.
A lot of things we will discuss in next semester, because you need to learn the difference between unconstrained optimization in economics, constrained maximization in economics. So a whole lot of things will be there. At this moment, the objective is to show you there are different methods to find out same equilibrium solution, or whatever be the mechanism, we will reach at the same solution if we want to find out consumers equilibrium. I understand many of you may face some difficulty with the Lagrangian thing, because Lagrangian thing, there should be the analysis of the background of constraint, unconstrained optimization, and then only we will be able to understand what is the mechanism of the constraint optimization. Okay, so in this semester in Mathico class, first you learn about nitty-gritties of unconstrained optimization, and then in the next semester we will discuss constraint optimization in the second Mathico paper, and then we will follow this mechanism to derive consumers equilibrium as an application of that mechanism. Okay, we will learn much about this, because the second order conditions etc. are not simple here. So we have to talk about Hessian determinant, bordered Hessian determinant. Too many things are there. Okay, so we will not make the things clumsy now. Just keeping in our mind, apart from the graphical method from where we are developing the equilibrium condition intuitively, there are several other formal methods as well. So that point only we are keeping in our mind. Method 3. Method 3. Method 3 is, a kind of doing the things algebraically. Okay. So here the income constraint is like this. So I can write y in terms of x. So xpx plus ypy plus I is equal to 0. That we can write, so everybody I hope has pen and paper with you. So first write down this equation, xpx plus ypy plus I is equal to 0. And from there, adjusting the equation, please check whether you are getting y can be presented in this format. Once you complete this, please let me know.
It would be minus sign.
Okay. Then the problem can be written as max u xy is basically max u x comma I minus xpx by py. I minus xpx by py. So I will like to maximize u. One student asked me the question, why I am trying to handle L, not handling u. And I told I have to incorporate the constraint along with the objective function, and then only I'll be able to handle that L function, not u function, because L function is taking care of the constraint along with the objective function. Now coming here, what I'm doing, I am internalizing the budget constraint in a different way. From the budget constraint, we are writing y in terms of x. Okay, so here directly I can maximize u function. Directly I can maximize u function because here also I am internalizing my budget equation. Instead of y, I am writing this as I minus xpx by py. So I am internalizing the budget in place of y. So directly I can maximize the expression u of x comma I minus xpx by py. Okay, now please do the thing on your own in your copy. Please write down totally differentiating the expression with respect to x. Totally differentiating the equation with respect to x. Because y I replaced in terms of x. So totally differentiating the equation with respect to x, we get with respect to x, the first order condition can be presented as totally differentiating the above expression with respect to x. The first order condition can be presented as next, del u by del x plus del u by del y into dy by dx. Okay, is equal to 0. Is equal to 0. Del u by del x plus del u by del y into dy by dx is equal to 0. Or in place of del u by del x, write down ux, u suffix x, plus del u by del y replaced by uy. Now, what is dy by dx? What is dy by dx? Look, go back to this expression. Y is equal to I minus xpx by py. Go back to the expression y is equal to I minus xpx by py. From this equation, we get dy by dx is equal to minus px by py. From the expression y is equal to I minus xpx by py, we get dy by dx is equal to minus px by py. So substituting dy by dx in this equation by px by py, we can write the equation as ux, u suffix x plus u suffix y into minus px by py equal to 0. This finally gives px by py is equal to ux by uy, or px by py is equal to mrs xy. Okay, so tell me if anyone have any difficulty in understanding. So this will be the first step, ux plus uy, dy by dx is equal to 0. Then I am getting dy by dx out of the equation y is equal to I minus xpx by py. I am getting that to be minus px by py, so I am substituting that.
Ma'am, from exactly which place did we start the total differentiation?
Total differentiation from where?
From which step exactly?
Okay, so max u of xy is equal to u of this. You have this equation?
Yes, ma'am.
After that, totally differentiating the utility function with respect to x. The
Actually,
first order condition can be written as
my writing order got a bit mixed up, so I was asking.
would you be a bit louder? I'm not getting you properly.
I was actually saying that my writing order got a bit mixed up, so I asked it.
Okay, okay. Now it's fine to you?
Yes, ma'am. Now it's fine.
Okay. Anyone else? Any other question?
Ma'am, in the first line, it would be minus I.
Minus?
I.
Yes. Yeah, there is a mistake. Yes, very good. There will be minus I. I'm sorry, there is a typo. I missed it. Thank you. Anything else? So these are the three methods by which we can derive consumers equilibrium. At this moment, the first technique is most crucial to us because here we are blending the graph with the idea of mathematics. Okay, so the first idea, intuitively, how we are coming to the reaching at the mathematical condition that the slopes of the two curves will be equal to each other at utility maximization. This is most important to understand. Okay, and this idea, why the equality is giving the equilibrium solution and why greater than or less than type is not giving any equilibrium solution. Okay, that is also crucial to understand. Okay, so this part is most important to understand. Now, if this part is understandable, in the next step, we have to consider the corner solution. So we learned about the interior solution. So now we are going to understand the corner solution. We are going to understand the idea of corner solution. Okay, so today just I'll initiate. We will discuss this or elaborate this in the next class. Okay, since Friday we will have the presentation, not the usual class. Just I am initiating the idea. However, we will continue from this point in the next week, Monday classes. We will continue from this point. Okay, so for an interior solution, we are getting Px by Py is equal to Ux by Uy. However, sometimes consumer gets highest utility level when X is equal to 0 or Y is equal to 0. If that is the case, we have corner solutions. And in that case, obviously, Px by Py is not equal to Ux by Py, Ux by Uy. So for the entire budget line, if it happens, for the entire stretch of the budget line, if it happens, Ux by Uy is greater than Px by Py, consumer will continuously substitute X by Y. Consumer will continuously substitute Y by X because to the consumer, the valuation of X relative to Y is always greater. Valuation of X with respect to Y is always greater than what she is paying for additional unit of x with respect to y. So ux by uy is greater than px by py always. If this happens, naturally the consumer will continuously substitute y by x. So at the end, consumer will stop when y is equal to 0, because that is a point along the axis. I'll be not able to go beyond that. I'll be not able to increase my consumption of x beyond that, because in that case y will become negative. So negative amount does not make any sense. So I have to stop there. However, my will be, continuously increase the consumption of x. Alternatively, if ux by uy is less than px by py for the entire span of my budget line, I will continuously substitute x by y. And finally, I'll stop when x is equal to absolutely 0. X is absolutely equal to 0, because I'll be not able to increase my consumption of y further, because for that x will become negative. So we are consuming along the axis. Y is equal to 0 means I am on x-axis. X is equal to 0 means I am on y-axis. Okay, so if this happens, that means I am considering corner solutions. So this is my budget line. Continuous substitution means I am either at this point or I am at this point. Okay. So finally, my equilibrium will be attained either at this point or at this point. Naturally, this is a corner solution. This is a corner solution. Okay, so we will start from this point in the next class. Now, before closing, okay, our presentation of the project you developed, that will be held on Friday. First, Z8 sir will take your class. After that,